Hello dear students. In this video we are going to continue with our BP regulation, and in this video we are going to look at the intermediate and the long term. In the previous videos we saw about the short term regulators. In the short term we have already seen the baroreceptors, the chemoreceptors and CNS ischemic response. Today in this video we are going to look at the intermediate regulation and the long term. Out of the intermediate and the long term is the most important, that is the RAS mechanism, which we are going to discuss. In the intermediate, we have few short mechanisms which can regulate the BP and try to bring back the BP to the normal levels. One is the renin-angiotensin vasoconstriction mechanism. Whereas the entire RAS mechanism is long term, yes, a part of RAS mechanism, which is the vasoconstrictor property, happens a little early. That's why we have put it in the intermediate regulation. Then there is capillary fluid shift. What is this capillary fluid shift and what is this stress relaxation of this? We are going to discuss. So coming to the intermediate regulation of the BP, the first mechanism, that is the renin-angiotensin vasoconstriction mechanism. This will be discussed along with the long term because it is a part of the long term arm, but the primary angiotensin that is forming and it can cause vasoconstriction at an earlier stage. Then next comes the stress relaxation of the vasculature. What is the stress relaxation of the vasculature? It's a very simple mechanism. So whenever the BP is increasing, what is going to happen? Whenever there is, let's assume there is an increase in BP in this particular blood vessel. Now the blood vessel is going to dilate because of the increased BP. And this dilation, whenever it is prolonged for a longer time, so when the pressure in the vessel becomes high and it is prolonged for a longer time. So that is the most important aspect, prolonged for a longer time. If it is prolonged for a longer time, what is going to happen? The vessel is going to be stretched, and this property, you will read it in the smooth muscles also. They will have a property to relax whenever they are stretching too much. When we stretch them, after some time, they will relax and then they will try to maintain that levels of the stretch. So now there will be relaxation of the vessels. But is it going to happen on and the pressure is not going to increase? The answer is no. This mechanism is going to happen for a short while, and this stretch will cause a slight relaxation because of the plasticity nature of the vessels or the smooth muscles. And after that, if the pressure is constantly increasing, then definitely the BP is going to increase. So this mechanism is not that much effective, but it provides a slight decrease in BP for an initial state. Next, there is capillary fluid. This is a very simple concept. Suppose let's assume whenever the pressure is high, suppose the hydrostatic pressure is high. If the pressure is high here, what is going to happen? The hydrostatic pressure is going to push the solution into the interstitial space and decrease the BP. So this is one mechanism. Suppose the BP is low. Whenever the BP is low, what is going to happen? The capillary pressure, when it falls, the fluid is low here. So what is going to happen to the concentration of the proteins here? Now the capillary pressure is low because the fluid volume is low. So the capillary proteins, the proteins concentration is going to increase. If you have studied the basic concept of protein has a tendency to pull the fluid towards it. So it can attract the fluid towards it. So what is going to happen? Now the fluid is going to move into the vessel. So when the capillary pressure falls, there is an increase in oncotic pressure. This oncotic pressure is caused by the proteins, and this will increase the fluid volume. And what is going to happen? There is going to be an increase in blood pressure. We started with a capillary blood pressure fall or a decrease in BP. So that's how, if there is an increase in BP, the vice versa can happen. If there is an increase in BP, what is going to happen? The hydrostatic pressure is going to happen and push the fluid into the interstitium. In this way, it can regulate the BP to a slight levels. So these are the two important mechanisms in intermediate regulation. Coming to the long-term regulation of the blood pressure, the long-term regulation is primarily done by the kidney. The one advantage of this is the regulation done by the kidneys. Suppose the BP change is happening, let's assume from 120, the BP is going all the way up to 180. The baroreceptor can bring back the BP to the levels of 140 because now the levels have gone up so high. But it is the renal system which is bringing back the BP back to the level of 120. The error in the renal system is almost zero. It will exactly bring back the values to the same initial values. That's the capacity of a renal system. It is slow, but it is very, very powerful. And this is even developed in primitive animals like a hagfish, like small fishes. They have also developed this mechanism nicely. So what the kidney is going to do, both for an increase in BP also it is going to work, as well as for a decrease in BP. For an increase in BP, what is going to happen? There is going to be a increased renal plasma flow, and there is going to be an increased renal flow, or GFR. So that will cause something called as pressure diuresis. Because of the increased pressure, it is going to cause diuresis. Not only that, because of the increased pressure, it is going to cause something called as pressure natriuresis. What is natriuresis? It is nothing but increase in the sodium exit. Whenever sodium is exiting, who is going to exit along with them? Sodium spread, that is nothing but the water. And there will be a decrease in the renin, angiotensin, aldosterone system. Whereas if there is a decrease in BP, it is going to increase the renin, angiotensin, aldosterone system. So as you can see from this chart, whenever there is an increase in BP, we have to decrease the RAS system. Whenever there is a decrease in BP, the RAS system is going to increase and help to bring back the BP to normal levels. So how does this RAS mechanism work? Let's try to understand further. So the RAS mechanism's role in arterial blood pressure control. So this mechanism is called as renin angiotensin. It doesn't stop with angiotensin. It also forms one more component which is called as aldosterone system. So this is the entire system. They are synthesized. First, the primary product renin is synthesized and stored in a particular region of the kidney, which is called as JG cells. This cells is called as juxtaglomerular cells. In the renal system, we'll be reading about an apparatus called as juxtaglomerular apparatus. Out of them, one of them is the JG cells, which is going to produce the renin. Where it is present? It is present in the afferent arteriole. In the kidney, there are two types of arteriole. One is the afferent, another one is the efferent. So afferent is going to come and efferent is going to exit. It is present in the afferent arteriole. So what is going to, it is going to sense us whenever there is an arterial blood pressure fall, JG cell will secrete renin, which we have understood. So the primary stimuli for it is, it can be a hypovolemia or it can be a hypotension. Both the pressure decrease as well as the volume decrease will be sensed by the baroreceptors in the JG cells. And whenever there is a volume decrease, there is going to be a decreased load to the macula densa. What is this macula densa? Again, it is a part of the juxtaglomerular apparatus which is going to sense the sodium and chloride. Now, there will be a decrease in the sodium chloride levels. So, it is going to give a tubuloglomerular feedback and increase the levels of renin. All this mechanism you will read in detail in the renal system. Next thing is there is an increased sympathetic nervous system activity which can directly stimulate the JG cells. So first thing is whenever there is a pressure decrease or a volume decrease, this volume decrease will deliver a less amount of sodium chloride to the macula densa, thereby stimulating the renin production with the help of tubuloglomerular feedback. Then all these things, whenever they are stimulated, now we have the production of renin. So the renin will be produced. So renin, when it will be produced? Whenever there is hypotension, decrease in BP. This renin is an enzyme which will convert angiotensinogen into angiotensin 1. Where is this angiotensinogen is produced? It is produced from the liver. As you can see here, now one organ was involved, the renin is produced from renal system. Now it is helping its friend liver to convert the angiotensinogen to angiotensin 1. And again, angiotensin 1 is not an active form, so it should be converted into angiotensin 2 with the help of an enzyme, angiotensin converting enzyme. This pathway, again, it is mandatory to read in first year, because again when you go to the second year, there will be a lot of drugs. Suppose, for example, in a hypertensive patient, what we have to do? We have to decrease the RAS system. So we'll be targeting the areas like angiotensin converting enzyme inhibitors, because we don't want the RAS system to increase in a hypertensive patient. Suppose a hypertensive patient comes to you, we have to ultimately decrease the RAS system. So we have potential drugs like angiotensin converting enzyme inhibitors. So once you know the pathway, it's easier to understand the pharmacology also. Next, angiotensin 1 will be converted to angiotensin 2. Angiotensin 2 is an active form. This angiotensin 2, as soon as it is formed, what is going to happen? It is going to cause vasoconstriction. This action is faster, and that's why this is considered as an intermediate mechanism. Why? Because its action is going to be faster. As soon as angiotensin is formed, it is going to cause vasoconstriction and increase the BP. That is the intermediate mechanism. Whereas the other mechanisms like sodium and water retention, It is basically going to help the nephron to reabsorb sodium and water. That mechanism is slower, so there will be a slow increase in the fluid volume, which will increase the BP. So there was a decrease in BP. Now, because of this fluid and sodium retention, there is going to be an increase in BP, and there is going to be a simple vasoconstriction also. Not only that, this angiotensin 2 also can stimulate adrenal. Whenever it is stimulating adrenal, it is going to form a compound that is called as aldosterone. Again, this aldosterone is going to act on the nephron to form sodium and water reabsorption. So what is going to happen to the BP again? Again, there is going to be increase in BP. Finally, after all its action, the angiotensinase is an enzyme which will make it into an inactive form. So that's how the angiotensin or the renin angiotensin aldosterone works. And this system has a potential to bring back the BP to almost back to the same original levels. And this system is slow, but it is very, very powerful. So this brings us to the end of the BP regulation. We have done short term, intermediate, and long term. This is one of the most important questions for your final exams or all any kind of exams as well as in Viva. So make sure to watch all these 3 videos again. Thank you so much. Keep on supporting the channel. Stay tuned for more such videos. Thank you so much.